Tell the girl what to do, Lily. Stay with her. Tell her what to do. Oh, no.
So we're going to make sure that the rope is straight. Alright? So you guys have to watch for us, alright? You tell us that to make sure that the rope is straight. She's going to be on this side to make sure that they're actually keeping the rope straight. So you guys ready? So this isn't tug of war, guys, alright? This isn't tug of war. It's not limbo either. So what she's going to do is you're going to put your hand here. And you're going to make sure that it's straight, so you're just going to pull it down to make sure that they're keeping it straight. So is it straight, guys? No! Okay, guys, pull hard. No! So go ahead and push. Is it straight? No! Alright, guys, really pull hard. Really pull hard. So, I don't know. We have two strong guys here. Alrighty, guys, alright. I think you guys have enough. Let's see if maybe they just need more help, right? Maybe they're not putting enough force, right? So let's get two more assistants. Come on. All right. So let's see. We have two people on that side, two people on this side. Okay. So everybody cheer on for Jasmine. Who do you think's gonna win? We have four guys on one guy.
Jasmine.
So everybody. So, you guys are pulling? Make sure that they're pulling. I don't know. I think she's still... Alright, round of applause for Jasmine. So, what happened? What happened here? Jasmine, she's so small, but yet she beat the four big guys. Alright, so let me tell you. We had two people on this side, and they're pulling in this direction, right? Then we had two people on this side, and they're pulling in this direction. So we had balanced forces in that direction, in this direction, right? Now, we had Jasmine pulling down, but who was pulling up? Nobody. There was unbalanced forces. It goes back to the same thing that we were saying earlier. The objects move in the direction of the greater force. Since she had no other force pulling up on her, there was no one to fight. So she was able to pull down the rope with no problem. So thank you again, Jasmine. Thank you again. Alright. So now we move on to... Alright, so actually now we have something called momentum. Have you guys ever heard of momentum? Momentum. So you can think of momentum as transferring energy from one object to another. Now momentum depends a lot on the mass of the object. You guys know what mass is? Yes! And so we know that mass is the number of particles that are inside of this object. So which one has more mass? This one or that one? That's bigger. That's more mass. So what do you think is going to happen if actually, first I have to ask. So if I let this ball go, will it ever come back to the same height? Yes? No? So we're going to do something that we always do in science, which is test things. We're going to test our hypothesis. So will this come back to the same height? I hear some people saying yes. I hear some people saying no. Okay. So let's see. Ready? 3, 2, 1. It didn't come back to the same height. So here we go. Now let's do the basketball. Will the basketball come back to the same height? Yes. All right. Ready? 3, 2, 1. So in it didn't come back to the same height. So what happens, what do you think would happen if we were to hit the ball with most mass on top of the ball with little mass? Alright, so ready? We're going to test it out. Now, 3. Wait. Well, actually, I have to say, be ready if the ball comes in your direction. Be ready to catch, okay? Okay, here we go. Now, 3, 2, 1, go. Okay, so it stayed pretty low to the ground. So, what do you think will happen if we put the opposite way? What if we put the more massive object on the bottom and the least massive object on the top? The ball's going to go far. Alright, so now let's see what happens. Ready? Be ready to catch. Now, 3, 2, 1. Alright, so the ball is flying now. So, this is something that you could try. Here we go again. Ready? 3, 2, 1. Okay, so now we're doing a lot of concentration for this one. So my friend Andre recently applied to be an astronaut for NASA, and he really wants to be in a rocket, but they haven't called him back. So he decided to make his own one. So guys, I have to say, do not try this at home because this is very dangerous. Now, I have to say that this is very loud. So you guys might want to cover your ears. Alright, who's going to give me the thumbs up? You ready? Alright, you ready? Alright, remember, you're a professional. Do not try this at home. We're going to count them down from 5. T-minus 5 seconds. 5, 4, 3, 2, 1, go! And he's up to the moon! Alright, guys, I have a question for you. So, who can tell me what Newton's law that was? So, do you guys know what Newton's law that was? Momentum? It's the third law. It's also known as the law of action-reaction. So, he pushed the fire extinguisher, right? And all the particles were going out in that direction. There was nothing to hold them back, so he started flying out in that direction. So thank you so much. So, here, have you guys ever heard of a guy by the name of Bernoulli? No! Bernoulli said a lot of cool things regarding air and fluids. So, guys, I'll come back over here. Let's take a seat. That way everyone gets a fair chance to see. So, come on, guys. So, this one is another one that you could try at home. So here we have a normal air dryer and a ping pong ball. Now, if we turn the air dryer on, you'll notice something interesting happens. Bernoulli said that the faster moving particles create low pressure. Now what happens here is that the air starts going around the ping pong ball. This is the most interesting part, that the air is going around it, so it's actually not just going around it, but it's like if it's holding it in place. So you're able to do something that's pretty interesting. Now look. It's floating over my hand, but there's nothing there holding it. It's just the air. The air is like going around the balloon, around the ping pong ball and holding it right in place. So can everybody see this good? I don't think so, because there's some people in the back, and I'm not sure if they can see it. I think we should get something that's a little bigger, yeah? So here we go. I think we have a ball that's bigger. Now, what do you think is going to give us a lot of air? A leaf blower. Here we go. So here we go. We have a little piece of toilet paper. Now, here's another demonstration that you can try at home. So guys, okay. So here I have a piece of toilet paper. This one you can try at home. This is completely safe. So here we're going to do the same thing. We're going to create what's called lift. Do you know where we see lift every day? It's airplanes. Airplanes use the same concept of lift. So here, all we're going to do is I'm going to blow over this piece of paper. Over this piece of paper. So now you see that by blowing over the piece of paper, the paper will actually go up. The paper's going to go up rather than, because if you blow into the paper, it makes sense that it's going to go up, right? Here we go. That makes sense. But what if I blow over it?